So hey everyone, in this video we are going to give this contest live. This is Biweekly Contest 172. We'll be solving all the problem. Hopefully we'll be solving all the problem. Let's see what happens. So there is still 20 seconds left. Okay, so the contest has started. Now let's join the contest. The recording is going on. Yeah. It is loading. Okay, there might be some issue with the server. Let me refresh the page. Okay, so there. Okay, so this is the first question. Minimum number of operation to have distinct element. Okay, so we have 3 medium problem and 1 hard problem. Okay, so we'll be given an array nums. In one operation you remove the first 3 element of the current array. If there are fewer than 3 element remaining, then all the remaining element are removed. In one operation you remove first 3 element of the current array. Okay, so the only first 3, right? If then 3 element, repeat this operation until the array is empty, contain no duplicate value. Okay, so we have to repeat this operation until there is no duplicate value or the array is empty. Return an integer denoting the number of operation required. So as it can, okay, so as there can be at most 10 to the 5 number of element, then we can go with the naive approach. So I think there is a follow-up question for this. No. So yeah, we can just simply create a map which will be storing the frequency. Yes, and after that we are going to iterate from the left to right and see if we need to remove the element so that okay, so we need to first count the number of element that is there which has a frequency more than 3. So set of integer, no, like which are duplicate actually, my bad. So this will be containing all the elements that are duplicate. So if mp of it is greater than or equal to 2, that means that there is a frequency of more than or equal to 2, then we'll be adding those element to the duplicate set. Why we are using set? Because there can be multiple multiple time we are going to insert the same element, so we had to just keep the count. So yeah, that's why we are using the set. So count of duplicate element are going to, like, count of duplicate is going to be the size of the duplicate set, dop dot size. Now we need to remove those. So while there is no duplicate, so count of duplicate is greater than 0, that means that there is duplicate element in the array, we are going to do what? We are going to iterate from the left. So let's say the index is 0. We are going to start from 0 and we are going to remove 3 elements at once. So if I is less than, let's say the size of the array is n, if I is less than n, then remove that element, mp of psi minus minus, and if the frequency turns out to be 1, that means that we have removed all the duplicate elements, so count of duplicate will be decreased by 1. Okay, makes sense. Yeah, that makes sense. And we're going to increase I, and we're going to do the same 3 times. Yeah. And at each step we need to increase the number of steps by 1. So there will be a variable that will be storing the number of steps. And in the end we need to return the number of steps. Step or steps? What was the variable name? Here, step. Let's see if it is passing all the test cases. The output should be 1, 1 and 0. It is 1, 1 and 0. Yeah, looks good to me. Yeah, it is accepted. So let's go to the next one. Maximum sum of 3 numbers divisible by 3. You are given an array, integer array nums. The task is to choose exactly 3 integers from nums such that their sum is divisible by 3. Return the maximum possible sum of such a triplet. If there is no triplet, then return 0. So we need to choose exactly 3 integers such that the sum is divisible by 3 and the triplet sum should be maximum possible. Okay, 4, 3, 2, 1. Okay, so our target should be to include all the maximum element, like all the largest element possible. Like we should first go through the array in sorted order from the largest to the smallest one, and we should first check if we can include that element in the triplet and create a sum such that the sum of the triplet could be divisible by 3. Is this how we are going to do that? Not so. Let's see. So 4, 2, 3. These 3 are the largest one that has a sum of 9. But that is not always going to be true. So divisible by 3, right? So there can be remainder 1, 2 and 0. Yeah, this through the only possible remainder that could be there if we sum up such a triplet. Let's try. Yeah, what could be the edge case if we try to only include the maximum element? So suppose if we are going from the largest to the smallest. Okay, let's dry run this a bit. So suppose there are elements sorted in uh, descending order: 9, 8, 6, 4, 2, let's say 15 is there. So suppose this is the array. So if I go from here, if I include 15 plus 9 plus 8, they are going to sum up to 15 plus 9 is 24 plus 8 is 32. 32 modulo 3 is going to be 2. So we are going to say that okay, we need to remove any of these 3 elements and add one other element. Is this the case, or we are going to remove 2 elements from here and remove, like, get a 2 complete different element from the array? Or are we going to remove all the 3 elements? What are you going to do? So 15, by adding 15 we are adding a remainder of 0. By adding 9 we are adding a remainder of 0, and by adding 8 we are adding a remainder of 2. So to neutralize this or to cancel this out, we need to either replace 9 with an integer that has a remainder of 1, so that this 2 can cancel out and get a remainder of 0, or we can remove 8 and get a number which has a remainder of 0, so that all the summation would lead us to a summation that have a remainder of 0. So 6 has a remainder of 0. Here we can remove 8 and add 6. But yeah, that makes sense. This is the largest triplet available that has a summation remainder of 3. So the sum will turns out to be 15, 9, 24 and 30. 30 modulo 3 is 0. And 30 is the largest sum possible. Yeah, that is fine, but what if there was no 6? Let's take another example. Let's say there was 16, 9, 8 and 6. Suppose this is the array, and we are going to take these 3. So 16, 9 is 25 plus 8 is 33. Okay, this is a bad example. Let's say the array is 16, 9, 7, 6. So 16, 9 and 7 will be adding up to 32. That will have a remainder of 2. So we need to remove element and add this 6. Okay, so 16 is going to give us a remainder of 1. It will be 0. 6, 7 is going to give us a remainder of 1. So we need to remove 9 with, like, we need to replace 9 with an integer that is going to give us a remainder of 9 will be replaced with an integer that will give us a remainder of 1, so that this 3 can sum up to be 3. Or we can replace 7 with an integer that is going to give us a remainder of 2. So this 2 can be added to get a remainder of 3. That means the remainder 0. So suppose there were both the option. So suppose we had an element, let's say less than 7 and has a remainder of 2, that is the number. There is 5 and 8, but since 5 is the smaller, like 5 is smaller than 7, that should be 5. So we could either add, like replace the 7 with 5, or we could replace this 9 with a number smaller than 9 but has, like smaller than 7 but has a remainder of 1. What is it? It is 7 itself, right? Yeah. Suppose there was one more 7, and then we could just replace this 9 with 7. So if we replace 9 with 7, then what will be the summation? So 16, 7 and 7 with theories, and this will be 16, 9 and 5. This 9 is coming over here, and this 7 is getting replaced by 5. So okay, so in both the cases we are getting the same number. Okay, so it doesn't matter actually. Yeah, it doesn't, right? No, actually it does. Suppose 9, like instead of this number, there are a number, let's say 160, 90, and 7. And this is giving us a remainder of what? 160, 150 is 0. So it is giving us a remainder of, suppose this is divided by 3. So it will give us a remainder of 1, because 159 is divisible by 3. 90 will give us a remainder of 0, and 7 multiplied by 3 is 1. So if we had an option to replace 90, it will always be worse than replacing 7, right? Yeah, so if we had a number 6 and a number 5, so it will always better to replace 7 with 5 instead of replacing 90 with 6. Yeah. What we are going to do then? We can do one thing. We can say that, okay, how many numbers are there which has a remainder of 0? How many numbers are there which has a remainder of 1? And how many numbers are there which has a remainder of 2? And what we will do, we will try to combine each of this number to get the maximum triplet. Yeah, that is what we can do. Yeah, that should be a better approach. Let's say R0, R1 and R2. Okay, so what we can do, we can sort all the array r0 dot begin. Now we are going to take the largest among all. So suppose we want to create an array which has only the number that are 0. Let's say maximum is the maximum possible answer. And if no such triplet exists, then the answer should be 0. So we are saying that at first we are saying that there is no triplet that does exist. So the summation is turns out to be 0, and we are going to try adding all the element that is going to give us a remainder of 0. We are going to add the largest 3 element. So for int I equal to 1, I less than equal to 3 plus plus. Let's see. If r0 of r0 dot size minus I is greater than 0, greater than equal to 0, just in case we are going to check if we have added at least 3 element or not. If this gives us a remainder of 0, then we can say that if sum is greater than answer, which is going to be, no, not answer, it is maximum, then maximum will be updated to sum. Yeah. Now we are going to do the same for 2 and 1, I believe. Yeah. Sum is resetting its value to 0, and instead of r0 we are going to say r1. And going to be r2. What? Oh, this is r2, this is r2, this is r1. So where is r0? Yeah, now it looks good. Yeah. Yeah. And now what else can happen? We can say that, okay, first reset the value of sum to 0. Now we can say that we might add the remainder 0 with the remainder. Yeah, there can be 2 0 And what else can be there? There can be 1 2 and 1 1, that will sum up to be 3. There can be 2 1. No, there can't be anything else, right? That will give us a sum of 3. 0 0 0 1 1 1 2 2 2 and 2 1. Yeah. So if r2 dot size is greater than 0, then sum plus equal to r2 dot back, and if r1 dot size is greater than r1 dot size is greater than 0, but wait a minute, there could be edge case. Okay, if r1 dot size is sum plus equal to r1 dot back, zero 1 2, right? Yeah, r0 dot size is greater than 0, r0. I should have used a 2D array of 2, like 3 cross 3 instead of like 3 of size 3. Yeah, instead of 3 separate arrays. r0 dot back. So if count is 3, then only do that. Okay, and sum is greater than max, then max should be updated to sum. Okay, and one more thing. I was assuming that if there are 3 elements, then only the remainder would be 0, but no. If there are 2 elements, then also it might give us a remainder of 0 for this case. r0, where is r0? Here is r0. Count equal to 0. And count will be reset to 0. Yeah. For the case of 2 plus 2 plus 2, yeah, there has to be 3 number. For 1 as well, I don't have to worry about this 2. Yeah, it should work. It is giving us a runtime error. Looks like we are accessing something that was not supposed to be accessed. R2 is there, right? not -1, -j, no, -I. Int j equal to r2 dot size -I. Yeah, that should be the syntax. This should be r1. This should be r0. Nine and 0. What is 0 and 0? Why is it 4, 3, 2, 1? Let's do a try run. 4, 3, 2, 1. So R0, R1 and R2. In R0 we'll be getting 3, nothing else. In R1 we'll be getting, in R1 we'll be getting 1 and 4, and in R2 we'll be getting 2 only. Now what we'll do, we'll try to see this one. Okay, this one is also not possible. This one. So 3. Yeah, this should work. Why is it not working? Let's try to print all the sum. In this case, like in the fourth sum, there should be 9, right? No, looks like it is giving us a different answer. The first sum is the sum of number that has a remainder of 2. So it is giving us 2, that is fine. Second sum is the number that has a number of 1. 1, 4 and 5. It should have given us 5. Which one is it? 4, 3, 2, 1. It should be giving us a summation of 5, not 8. Okay. If it has a remainder of 1, then it should be pushed here. If it has a remainder of 0, then it should be pushed to R0. Then it should be pushed to. Now 2, 5 and 3 for this one, and 3 plus 4 plus 2, that is 9 for this one. Yeah, so it is working fine. It is working fine. Okay. Yeah, it is accepted. And now let's go to the next one. Maximum score after binary swap. You are given an integer array of length n and a binary string s of the same length. Okay, initially your score is 0, each index I, where si is equal to 1. Okay, so if contain a character that is 1, that contributes num I to the score. Initially your score is 0, each index I. Okay, you may perform any number of operation. In one operation you may choose an index I. May choose index I, where I could be anywhere in the range from 0 to n minus 1. No, anywhere in the range 0 to n minus 2. And si is 0 and si plus. Okay, so I can choose any of the number from 0 to n minus 2 and swap it with the adjacent element if that has a different digit. Return an integer denoting maximum possible score you can achieve. So yeah, 21523. Let's take this example. Zero one zero one zero. So my goal would be to take all the maximum elements. So there are 2 1, so I can take at most 2 elements. So okay, alright, I think I got this. Any number operation, right? Okay, so because here is a 1, like the first index from the left where I will be getting a 1, I can say that okay, from here I can choose any number from the left to this index and I need to choose the maximum one. Okay, makes sense. So suppose I choose this one 2 over here, then I cannot choose anything on the left, right? Okay, that is also one problem. I cannot choose anything on the left if I have selected 2 here. No, maybe I can. Okay, let's say that okay, I can choose anything from here, and from here as well I can select any element. So with this one I will definitely choose the number 5 because it is the largest among all the number to its left, and then I have this one, like I can choose anything in this range, so I'll be choosing the number that is 2. Yeah. Makes sense. So what am I going to do? I am going to iterate from right to left, right? Yeah. And whenever I see 1, I'll be keeping a count of all the numbers that I am going to encounter from here, and I'll be storing them in a descending order, like from maximum to minimum. I'll be storing them in a priority queue, and then what? And when I'll be at the leftmost element, can I say that I can take all the element that are greater than that? No. Okay. So here basically I need to make a decision whether I will be selecting this one's or to its left. This is a greedy problem, but maybe I'll iterate from the left, and whenever I will encounter a 1, I will take the maximum element and add it to the answer. That should be a better approach, yeah, and it will work. Yeah, it will work. So let's say wherever there will be LL, I'll be using LL as long. So let's say L, we need to create a priority queue, and the topmost element will be maximum. Okay, so simple priority queue. So there are n number of elements. So I'll be iterating from the left to the right. So if I see a 1, then I have the ability to take anything on the left. Okay, I can take anything from the left. Yeah, that's what they are saying. 'That should be it. Seven and 0. Is it going to 7 and 0? Yeah, do I need to do a try run? No, let's see what happens. Okay, it didn't work. Okay, answer plus equal to pq dot top. Answer should be long. Okay, I should have thought about the edge case. I did a mistake. Looks good to me. Let's see what happens. Yeah, it is accepted. Got a penalty. That's pretty bad. However, we are able to solve 3 problems for now. Let's see if we are able to solve this one. We are given an integer n. We write the integer from 1 to n in a sequence from left to right. Then alternatively apply the following two operation until only one integer remains, starting with operation 1. Operation 1 starting from the left, delete every second number. We write the integer from 1 to n in a sequence from left to right. Then alternately we apply two operation until only one integer remain, starting with operation 1, starting from left, delete every second number. Okay, have taken LL over there, right? Priority key of LL, the size, and then yeah, that was a silly mistake. 5, 6, 7, and 8. So the first operation, the step operation 1, we are going to take all the alternative element, right? Starting from left, we delete every second number. So okay, every second number. So we are going to delete this one, this one, this one, and this one. So our remaining array would look like this. And second step, operation number 2, we are going to iterate from the right and we are going to remove every second number. So the remaining array would look like this. Third step, operation number 1. We are going to delete every second element, so it is going to be 3. Now n can be up to 10 to the power 15. So if we do this thing every time, so just how many times do we need to iterate? Like storing them will be taking 10 to the 15 size, that is bigger than 10 to the 8. So space complexity will not be optimal. And also the time complexity, we are going to cancel all the element by iterating over that. That means that we are going to go to each and every element for once. We can say that the time complexity is 10 to the 15. Yeah, like 10 to the 15 minus 1, which is same as 10 to the 15. So time complexity will also not be optimal. So there should be a better way. I'm going to delete this, 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 this. But deleting means we are going to take this, keep this, keep this, keep this one, keep this one, delete this one, keep this one, delete this one, keep this one. So 1, 3, 5, 7, 9, 11, 10, 15. Now if they have given only one type of a person, then the problem would be simpler, I believe. Like 7, 11, 15. Yeah. Then in that case we can say that okay, 1 would be the remaining element at each time. But they have modified the problem that okay, now this one will get deleted, this one will get deleted, and this one will get deleted. Okay, so deleting every second element from the right means that deleting every first element from the left. Yeah. Okay. Oh yeah, right. So keep 3, keep 7, keep 11, keep 15. Now delete the second one. So 3 and 11. Now delete the first one. Okay, so somewhere we are going to get to the middle. Yeah. But is it the exact middle? No. Why is it no? So there are 10 elements on the right and 4 elements on the 4 elements on the right and 10 elements on the left. What is happening to the left ones? Let's take a better example. I'm going to delete this one, delete this one, delete this, delete this. One, 3, 5, 7, 11. Now we're going to delete this, delete this, delete this. Three will come over here, 7 will come. Now we're going to delete this. Deleted. The last time also we had 11, right? Yeah, what is wrong with this 11 number? Why is it coming again and again? Okay, so even if we had, yeah, even if we had only number till 11, then also it will be coming up to. Okay, so it doesn't matter whatever there in the right of the 11, that is never going to be the answer, right? They will always cancel out. Yeah, because from the right it doesn't matter. We are going to cancel out the first number and the second number. That is how it is going. So it is going to start from the left and it is going to start deleting either from the first number or the second number. In the operation 2 we are going to delete from the first element, and in the operation 1 we are going to delete from the second element. So 11 is always going to be there. 11 is always going to be there. But what if there are less than 11 number? Then what number is going to be there? Let's see. Let's say 1, 2, 3. I believe it would be 3 because for 8 it was 3. So cancelling out from the second, this will get cancelled out. So 1, 3, 5, 7 and 9. Now it will start cancelling from the left. Yeah, it would be 3. Yeah, it would be 3. So any number that is more than 3 and less than 11, like less than 11 is going to give us the result as 3. Okay, what about 2? Suppose 1 and 2, then 2 is going to get deleted and we are going to get 1. Same for 1. So for number that is in between this range is going to give us a result of 1. For this it is going to give us a result of 3, and for anything that is greater than 11 and less than x, let's say, it is going to give us 11. But what is x? So to get any number that is on right of 11, we need to go beyond that. What is the pattern? Did you see any pattern? From 3 there is on the right, there are 2 elements on the right. 1 and then 1, 2, 5, 6, 7, 1, 7. 1, 7, 2 minus 1, 8 minus 1, 2 to the power 0 minus 1, 2 to the power 3 minus 1. Is it going to be 2 to the 5 minus 1? Is it going to be this 24? Let's see. Let's say there are number 24 number. 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 13, 14, 15. This one deleted, this one is deleted, this. So this one is deleted, this one 23, 24. This one is deleted. All the even ones are deleted. Okay, so even number has no chance. They are going to get deleted at the very first operation. Yeah. 1, 3, 5, 7, 9, 11, 13, 15, 17, 23, 25. Now we are going to remove this one. Now this will turn out to be 3, 7, 11, 15, 9, 10, 23. I'll start from the second one. So this will, so 3, 11. Okay, still there is this 11 that is coming. How many more number do we need? Let's see. 3, 11 and 19. So 3 will be cancelled out, 19 will be cancelled out, and 1, 11 will be there. Okay. There were more number to its right. Okay, let's say there will be odd number, right? 23, 25, 27, 29, 31, 33, 35, 37, 39, 41. 23 came over here. Twenty-three, 27, 31, 35, 39. Three, 35. So the next number. Okay, still 11 and 27. So 27 will be eliminated. What could be the next number? 3, 11, 19, 35. 3, 11, 19, 27, 35. 8, 8, 8. Okay, maybe we found a pattern. 35 and 8, 43, 8, 7. Okay, now let's say 3, 19. 11 will be deleted and 43 would be the next number. Okay. Now this one also is pretty cool because 11 plus 16, 27 plus 16, 33, no, 59, it was 59, right? Yeah, this is also 16. So each time there is going to be cap which is going to double down. What is going to be the next number? 11 plus 32, right? 11, 43, 32. 43 plus 32 is what? 75. 75 plus 32 is what? 105, 107. Yeah, 107 plus 32 is 139, 1 just 171. Okay, 203. 135. Let's see. 11 is going to get cancelled out. 75 is going to get cancelled out. This one get cancelled out. In the next step, 43, 171, 235. What is the difference? It should be 64, right? 107 minus. Yeah, it is 64. Same, it should be 64. It should be 64. Okay, we started from the left, so now the second one. Now 43 and 171. Now this one and this one. Okay. And this has a gap of 171 minus 43. 8, 3 is 11, 4 and 5, 6. 128. Okay, I think I got the problem, but how am I going to implement this? 43. Okay, each time, so the first one is 1, the second one is 3, third one is 11, then 43, then 171, 2, 8, 11 and 43, 42, 32, 128, 2 to the power 1, 2 to the power 3, 2 2 to the power 5, 2 to the power what? 2 to the 7. Okay, so each time it is going to. Okay, I think I found the pattern. I think I can solve it now. So it is going to start from 1 and it is going to increase its power by 2. Like, yeah. It is going to multiply each number. Like the power is going to increase by 2. Yeah. No, it is going to multiply itself by 4. Yeah. That's, I can say. Yeah. Doing the largest of them. So we are going to keep multiplying 2 by 4 until we get a number that is greater than the number. Yeah. I think I can solve it now. And start. We're going to start from. Oh, 1 is 2 to the power 0 actually. And yeah, 1 is 2 to the power 0. 2 to the power 0. Okay, so the gap is. Okay, gap is 4. Okay, that is the gap, not the difference. Okay, alright. I need to be sure about that. So start is going to be the 1. And the gap is going to be 2 at first. Not int, but long, just to be safe. And gap is going to be 2. The best possible answer. Okay, and can be at least 1. So I can say that answer would be at least 1. So while start is less than equal to n, what am I going to do? I'm going to add this gap to the start. So start will be added by gap, and gap is going to increase by gap is going to multiply itself by 4. Yeah. And our answer will be start. Yeah, and it should work, right? N is 3. It is giving us 3 1 3 1 1 3. Output is 3 4. Okay, this is a different number. 1. What about 5? For 5 it is giving us 3, but here it is saying that it should be 1. Why 1? 1 2 3 4 5. Why 1? I'm going to delete this one. 1 3 5. 1 is going to get deleted. 3 should be the answer, right? Okay, not like that. Okay, I'm going to. Okay. Okay, deleting the second number from the right is not same as that one. Hmm. Okay, that's yeah. Deleting the second one is not always going to be the same as this. If there were not this number 21, then that should be the case. Okay. Okay, I did a blunder. Okay. If 20 was not there, 22 was not there, let's say, then 21 was not there. Start from 19. This, it is pretty different. Still one. Okay, at least I can say what are the numbers that will be deleted. It's not really. No, the gap is actually real. Yeah. So there is this array. This one. Let's say there are more. Now if I start deleting from the right, second, 13, 7. Yeah, the gap is still there. 1, 5, 25. Yeah. Plus 8, plus 8, plus 8. Uh, 33.
Where is that?
No, I don't know the right range. How can I say that this is where it is going to get deleted? If it is ending at 23, then it is different. If it is. No, it is not different, right? Wait. Suppose there was one other number. 29, then these are the ones that would be deleted. And I would be getting 5, 5, 13, 21, 29. So the gap would be still plus 8, plus 8, plus 8. But the number will be swapped. Not swapped what? Yeah. I don't know how much time is left. There are only 4 minutes left. How many submissions are there? Okay, a lot of people have submitted this correctly. This should not be a hard problem. let's do one thing. And start to it's for 3 the output is 1, expected 3. Ah, okay, there is only 1 minute left. 9, 8, 7, 6, 5, 4. Okay, I think this was all for this contest. It is over.